that was physical change. That means boiling point is a physical property. If you color doesn't mean that color change. It means that if you color this this white board, you can color with a red color. That means there is no chemical change involved. And chemical property is when something is forming, chemical reaction is going on, right? So there is a couple of physical property involved in here in this problem, couple of chemical property. I want you to just try how many physical change or how many physical property, how many chemical property you see in here. Take a 1 minute to answer. What you can do, you can write down, I can take a look. Write down how many physical property you have, how many chemical property you have in this problem. Okay, so physical property, how many physical property you got? 2, 3, exactly. One is soft, second one is silvery color. Third one is melting point, is a physical property. And what are the chemical property? React with water. So all chemical reactions are chemical property. Any question?
No, sir.
Wonderful. Precision and accuracy. How these two words sound? Sound similar, isn't it?
Yes.
If you ask someone non-scientist, they would say, oh, they are both the same. Just say, no, two, they would say maybe synonyms to each other, right? And they use it all the time, the same purpose, same meaning, right? But being young scientist, you should know the difference between precision and accuracy. So, first of all, let's go accuracy. What does accuracy mean? The closeness to actual value, true value, right? So I have for instance, I have a beaker of water. It's 100. I have 100 milli water. I have in here. So if you take a graduating cylinder, if you measure it, if you get 99.99 milli, that shows that your measurement is accurate. That's exactly what accuracy means. How close, if it is, your measurement is close, the actual or true value, that's called accuracy. What is precision? That means, as you said, the repeatable results. When you're measuring something, no matter it's right or wrong, it's repeatable and reproducible. You're getting similar results or close results a couple of times. That means, look at that, it's completely different than accuracy. So you have 100 ml of water, and you calculate, you use this graduating cylinder, maybe it's a wrong, you don't know how to read the scale, and then you got maybe 10.0 milli. Actually, it has 100 milli. Is it accurate? No. And you say, and I said, hey, no, Megar, try again. They said, Dr. Haque, maybe try again. Yes, I'm right. Look at that. I got against the 10.01. And then I said, okay, try again. I know you are wrong. Try again. You said, Dr. Haque, I tried. I got 10.02 milli. You see? You tried 3 times because your scale is wrong, or you haven't learned how to read the scale. Then you got 3 different value, and all are far away from the true value. But your results is repeatable, reproducible. That makes you a lot of confidence and fighting with me, right? Maybe. So that's called precision. Is it similar to accuracy? Not at all. Completely different. That's called precision. And so one more thing you can see, accuracy, you don't need a couple of results. One trial is fine. And precision, you need a couple of trials because it needs to be reproducible, repeatable data. For instance, let's go to the example to see the difference between 2 definitions. For instance, you're shooting an arrow, and each time you're shooting a place, is it close to the true value? No, you're landing in the wrong place. But every time you same place but wrong place, right? That's called precision. But you are very precise but not accurate. How about the last one? Accuracy and precision. Because your arrows are landing in your target, your goal, but also they are close to each other. That's called accurate and precise. How about the middle one? Your arrows are landing all over the place, right? Is it accurate or precise? Not accurate, not precise. Because accurate have to be closer. Precise have to be reproducible. You have none, you see? That's called not accurate, not precise. Question? Can I ask you similar example? You can give it to me. Give me another example that accurate.
The weather?
Water? You're weighing, right? Suppose, or in the morning, you look at your weight, right? So your weight is 120 pounds, and but you go to scale, the scale is messed up. You're getting wrong value a couple of times. That means you're not accurate, but you're precise, right? Okay, no question. You can go significant figure. Have you heard these 2 words before? In different format, different times. But in chemistry, in measurement, significant figure is very important, extremely important to know. Sometimes students find, why should I need to know that? I know what is significant, how they look like, I know this is significant, and they don't appreciate that, but if you don't learn it, you're going to keep losing points throughout the semester because you're getting wrong sig figure. And if you know it, it's going to be very easy for you to sort out your right significant figure, write your answer calculations easily as a simple format. Because you know how many sig figure you have. So this is very important. We'll be learning. For instance, let me give you one example. For instance, the mass of Earth, or let's go mass of Sun. Mass of Sun is 20 and then 30 0. Look at that. You keep writing 0 0 0. So you're writing 30 0 after 2. So every time you're calculating mass of Sun, you keep writing, keep writing, keep writing. But if you know how many sig figure in there, that would be easy for you to write in a small format, in a exponent format, right? And let's see first what are the rules in sig figure. The first rule in sig figure is you have to have all non-zero. So, for instance, value I have in here 99.99 milli. Are they sig figure? Yes, because they are not zero. So any non-zero value are sig figure. What is the second rule? 0 between non-zero digit are significant. First of all, you write 5, 7, 8. This is sig figure, number 1 rule. Number 2 is 5, 0, 8. Right? 0 between non-zero is significant. Third rule is
Leading zero are not significant.
leading 0 are not significant. 0.001. So this has 3 significant figure. How many sig figure this has? 3 as well. Because it has a 0, but 0 is in the middle. So 0 between 2 significant figure are significant. Between 2 non-zero digit are significant. So this is it has a 3 sig figure. It also have a 3 sig figure. And how many sig figure this has? 1, right? And what is the fourth rule?
Terminal zero significant to the right of the decimal.
Very important rules that you need to very clearly. Let me give an example. If you have a 1000, if you have a 1.000, my question is, this 30, does it have any decimal? No. So if no decimal, zeros are not significant. So that means whole 1000 have only one sig figure. But if you have a decimal in here, so zeros after decimal are significant. That means I have a, how many? 4 sig figure you have. Let me give you a few more examples. That will be more clear. Okay, there you go. Take a minute to think about it. You don't have to answer right away. Just take a minute. Ready? Okay, first one. 3 sig figure. Which rules apply? 1, 2, 3, 4, 5. 0, 2 and 4, right? 2 and 4. So it has a 3 sig figure. Who can tell me why? Okay, I have a marker for you. Whoever get to the board, you can feel free to volunteer on the board. Write down the answer. You know, you get points, right? Writing the board. So first one is 3, that's correct. Because 0 between non-zero digit are significant. So this is significant, but this is not, because 0, the trailing 0 are not significant if there is no decimal. That's why this is not significant. Okay, 2.120. How many figure in here? So these 0 are significant or not? This 0 is significant. Why? Decimal involved, right? So 1, 2, 3, 4. 4 significant. Right? And 10,000. Very good. 1. 1.012. 4. Beautiful. Fantastic. 4. How about this one? It's already there, right? Okay. How many? 4. Any question? So 2 more rules applies on the significant figure. One is multiplication or division. Multiplication division, that means you have a question which have 2 values, 2 digits, right? 2 numbers, 2 independent, 2 separate different numbers. So these 2 numbers, how you calculate significant figure in the answer? That's the what rules about. So it says if answer should have least number of sig figure from the question. So for instance, if I have 2.12 and if I have a 12, okay, I'm multiplying that. Let me change a little bit. So I have 2.00 and I have a 40. Okay, I'm multiplying these 2 numbers. So let's see what is the answer. If you use your calculator, you'll be getting 8000, right? That's the answer you'll get. But look at that. How many sig figure you have in your questions? 2.00. How many sig figure you have in here? 3. How many sig figure you have in here? 1. Right? You only 1 sig figure. That's why the answer you have also answer have to have a 1 sig figure, which is
why do you have to have a 1?
only 8. But that's a big question. If 8, then answer is not right. Right? Then you make it 10. You make an exponent. This is called, you make an exponent in a 10 power. So 10 times 8, answer is correct, 80, but you also maintaining 1 sig figure. We'll talk about more exponent in the next section.
Wait, where you go one significant?
Because you do not look at the exponent. You look at only at the number that you have, which is only 8. 8 means only 1 sig figure. And why answer have to be 1 sig figure? Because in your questions you have a 3 sig figure or 1 sig figure. The rules is you follow smallest significant figure from the question, from the values given. So you have 2 numbers you have between 2, 1 and 3, you get 1 sig figure for the answer. So instead of 80.00, which you have a 4 sig figure in here, right? You cannot do that as an answer. Your answer has to be 1 sig figure 8, and 8 is not correct because you got 80. And that would be making it, then you can make a exponent which is 10 power. But answer is not same. So second is when you divide or add 2 numbers. When divide or add 2 numbers, how that it go? It goes, for instance, you have these two number this actual multiplication. You can see the example in here. You have a 4 sig figure and 2 sig figure. You multiply, answer have to be how many sig figure? So you have a 4 sig figure and 2 sig figure. Which one is the minimum sig figure? 2. That would be in your answer. So you got the answer from calculator, this 4 sig figure. You cannot keep it. So you have to keep only 2 sig figure. That is 7.4. You're cutting off in here. And what is you adding or subtracting? When you add and subtract, it applied that you taking the minimum number of decimal places. So you have a 2.51, you have a 2.1, so that you subtract it. See? You're subtracting these two, and you got 1, you got 4, you got 0, right? That's the answer you got in calculator. But you have to go back and see what is the minimum decimal points you have, not minimum significant number. Here you looked at minimum significant number, right? When you multiply or divide. But when you subtract or adding, you look at minimum decimal figure. You have 1 decimal number, 2 decimal number. So that means which one is, so you have a 2 decimal number and it has a 1 decimal number. Which one you can pick? 1, the lowest decimal places. That would be, can you keep it 0.41? And tell me, as it is 0.41, how many sig figure you have in here? 2 sig figure, because leading 0 always not significant. So you actually have 2 sig figure, but we don't count that way. We don't look at sig figure, we just look at decimal place. So answer would be 0.4. That would be the right answer because it still have a 1 decimal places. Decimal. So 1 decimal place. Right? So let me give you some problem. So for instance, look at see one more example you have. You're adding up. How many decimal places you have? First one? 3. How about the second one? 2. So finally you got this answer in calculator. Or you solve it manually, but you cannot keep 3 decimal places. Why? Because question have 2 minimum decimal places is 2. That's what you keep as a 2 decimal places to 8. And one more thing is how you make it 31.275 to 2.8. It was 7. What did you write? 8. You round it up. When you round it up, the place is retaining. That will add up 1. If the 1 is cutting off is 5 or more. So this is 5 or more. That's why 7 becoming 8. So I would like to give you some a problem. Solve this one. Anybody is welcome to write on the board, solve on the board. And you can extra comment, right? Yes, you can. Yes.
Wait, can I go on the board?
Sharon Moore.
Okay, so 6.8 914 divided by.
Right, we don't see it. Let's see.
Oh, is it?
Page.
Okay, 6.8914.
Anybody need help? Anybody else need help?
289
Everybody got it, right?
times
Okay.
7.28.
Let me know. Anybody needs help?
So since it's multiplication and division, you look at the significant terms. So it's 1, 2, 3, 4, 5. This one has 5. This one has 4. And this one has 3. So when you multiply these two, it equals 9.38392. And the least significant term is 3. So you take 3 of these terms and you get 9.38. So now you have 6.8914 divided by 9.38. And then that gives you that gives you 0. That gives you 0.735 because you're only taking 3 terms again for the 3 significant terms.
Let's
Yes. Wonderful. Good job.
Yes,
Let's see.
okay.